the FMEA is going to happen. And the only choice that you've got is you either do it up front, let the engineers sort it out, right? Or you let your customer do it in the field. And when the customer uncovers a problem in the field, it's a much bigger problem. So that's the way you kind of have to think about it, is it's going to happen. Where do you want it to happen? In a conference room before you've built 1,000 of them, or out in the field where you've got 500 of them out in the field and you're dispatching service technicians out to 100 customer sites to fix problems. And that's the way you kind of want to think about it.
We've worked with a couple of different larger companies, right, where we've designed a process to build their product, and their quality team will be in communication with them, and they say, have you performed the PFMEA? And the reason that they're asking that is because they want to know what is the risk associated with the product, with the process for the product that we're building. So when they ask that question, when we've conducted a PFMEA, they have a reasonable amount of confidence that the risk has been mitigated in that process. Where, again, the product that leaves our building, ships to them, ships to their customer, whatever it may be, meets all of the requirements of that product, what our customer expects that product to be out in the field. So like John just said, by doing a PFMEA up front before you've got all these units in finished goods or out at a customer site or in a warehouse, it's very, very, very costly to find an issue at that point and then have to fix it to units that have already been dispatched. Whereas if you do it up front, you mitigate that risk, or a certain amount of it. Now you can build product to a process that's been de-risked, and you have more confidence in the product going out.
Usually with this RPM number, which is the risk priority number, we'll set a bar at, like, say 200 or 180. It could go all the way to 1,000, but I mean, that would be, the thing is on fire. I mean, that's it can kill someone. It's going to happen every time, and we can't detect it during our inspection process. That's just wrong. So we'd set something at like 200, but that all depends upon how you rank the risk. What's the severity? Someone, are they going to be killed, or are they just going to need first aid, or are they just going to be annoyed, right? Or is nobody injured, but the product fails and the customer's going to be mad at you, right? So it gets lower and lower, and you can argue all day, well, that risk should be higher than this one, right? But so long as you come up with a standard way of talking about it, then when you do the PFMEA, it doesn't matter where you've drawn the line. You're going to have, it's like a Pareto analysis, right? 80% of the things that you have uncovered in this PFMEA are going to be low, but 20% of them are going to be bigger than those 80%, and some of them are going to really stand out. And you want to look at it and say, okay, let's start with the one that's RPN number, which is the risk priority number, right, is the highest. That's the one that we need to look at. And then you figure out, what are you going to do to make that number lower? Put additional quality checks in. That's, that works in many cases. Change the process to markedly reduce the occurrence of the problem. You can't really change the severity, because to judge the severity, you assume that it's going to happen, and you look at how severe it is. So the severity number you can't really fool with. Once you've settled on that, that's it. But you can increase the detectability, which will lower your overall risk, or you can change the process so that the occurrence is much, much lower, which will lower that overall risk. So that's kind of how you handle it. And then you go, once you've sorted that, you go to the next one. And you work your way down the list until you think, okay, the rest of these risks they're really acceptable. Now, in order to get our overall product risk down, we're going to have to do a lot more work. And if the severities are high enough, you may have to do that work anyway. But at that point, you're trying to judge kind of the expense of tamping the risk down more compared to the expense of fixing a few more units when you uncover the bad component. So first, from the safety standpoint, if it's a severe enough risk that someone's going to get hurt, you got to mitigate that. But once it's down to it's just costing you money and it's not costing people, fingers and eyes. Once it's down to just annoyance, really, then you can make kind of an economic judgment of how much more mitigation do you want to do to lower the risk of something going wrong and you having to repair something or something coming back.